equations. You did do this in Algebra 2. We will get a little more complex than you did there. You kind of just touched the surface. So we'll go just a little bit further than what you've seen before. But most of this will look pretty familiar, I think. So first of all, if I'm talking about an exponential function, do you know what that means? Can I say something that's exponential? It has an exponent. The variable is your exponent. So that's an exponential function. F of x equals a to the x. A just represents some number other than 1. It's called your base. And then the exponent is the variable. When we graph these, we are going to start out with making a t-chart. In general, we always require a minimum of 3 exact points when we draw this graph. So we're going to look at a couple and kind of figure out some properties of their graphs when they're increasing, decreasing, domains and ranges, those kinds of things. So here is our first one. F of x equals 2 to the x. So if you wanted to graph this and get some exact points, what do you want to plug in first?
1.
All right, so then 2 to the first is just 2. Right, if we did 2. 2 to the second is 4. What would happen if I put in a 3? 8 is just going to keep going up. Let's go the other direction. If we put in a 0, what's anything to the 0 power? Okay. If I put in a negative 1, what does a negative exponent do? Okay. So 2 to the negative 1 would flip it, and it would be a 1/2. If I put in a negative 2, it's like 1 over 2 squared, so you get 1/4. Will you ever do 2 to a power and get 0 for an answer? No. Can we ever do 2 to a power and get negatives? No. So our function looks like this. It's a curve, but it is just approaching the x-axis. It never actually hits the axis. The x-axis is the horizontal asymptote here, just the line we are approaching. What would be the domain of this? As you go from left to right, what x values do we hit? It keeps going both ways, so we eventually get them all. Range is referring to our y values. We're hitting everything above the axis, so everything positive. So it starts at 0, but it doesn't ever equal 0, so the 0 gets a parenthesis. It goes to infinity. Is this graph increasing, decreasing, constant? Increasing the entire time. And the only asymptote it has is the horizontal one at the x-axis, so that's when y equals 0. We don't have any vertical or oblique asymptotes here. Now I want to do the same thing, but I want to graph 1/2 to the x. So if you put in a 1/2 to the first power is just 1/2. If we put in a 2, 1/2 to the second would be what? If we put in a 0, 1/2 to the 0. We put in a -1. What's 1/2 to the -1? 2. If I put in a -2, 1/2 to the -2 would be a 4. So you'll notice these are pretty much the same, except what's different? This one's decreasing. My domain is still everything. My range is still 0 to infinity. I still have the same horizontal asymptote, but the difference is this one is decreasing the entire time. So in general, these exponential functions are always going to look like this. It's going to be a curve. It's either increasing or decreasing. What impacts whether it's increasing or decreasing? Okay. It's the base. If your base is bigger than 1, it's increasing. If your base is smaller than 1, it's decreasing. They always have a horizontal asymptote at the axis. In general, if we only needed 3 points, all you have to plug in are these would be -1, 0, and 1. Then you know that it's always increasing or decreasing. You know you have the asymptote. So those 3 points would give you everything that you needed. From here, we can do transformations, same transformations that we've always had. So I want to practice that. We're just going to graph some of these, doing a parent function and transformations. Skip over that, I think. Okay. So here is our function. We're going to graph it and give the domain range. So let's do the parent function first. When you get to your homework, I'm going to ask for the parent function. What would be my parent function here? Just 3 to the x power. And I told you, you really only need to plug in 3 points for that. -1, 0, and 1. So 3 to the -1, what does the negative exponent do? So it's 1/3. 3 to the 0, anything to the 0 power is 1. And 3 to the first is just 3. I'm going to draw my own graph. So we have -1, 1/3, 0, 1, 1, 3. That's my parent function, so when we do parent functions, they're always dashed. We know the axis is my asymptote here. So what would a negative out in front? Over. So remembering transformations, a negative in front is like making your y negative. So it flips it over the x-axis. So this point would become 1, -3, from 0, -1, a 1, -1/3. What's the domain? And that will be the true every time with an exponential. No matter what transformations you do, the domain isn't going to change. But my range this time, only hitting things below the axis. We don't ever actually hit the 0, so 0 just gets a parenthesis. Let's do a few more. So let's do 2 to the x plus 1. So my parent function is just 2 to the x. So we can just think about if I put in a -1, 2 to the -1 is 1/2. If I put in a 0, 2 to the 0 is 1. If I put in a 1, 2 to the first is 2. So there are my 3 starting points. What will the plus 1 do? If you add to the x, you go to the left. Remember, it moves it in the opposite direction if it's attached to the x. All right. So if we take each of these left 1, it looks like this. Domain, I said every time will be negative infinity to positive infinity. Did my range change this time? No, we're still hitting all the positives, so it's just 0 to infinity. Let's do one that has a couple transformations. So 2 to the negative x minus 3. So my parent function is just my 2 to the x again. So if we plug in -1, 2 to the -1 is 1/2. I put in a 0, 2 to the 0 is 1. Put in a 1, 2 to the first is 2. Okay, so then transformations this time. A negative on the x does what? Flip over making your x's negative, so it flips it across the y. And the -3 would move it when you move these graphs up and down, you have to move your asymptote as well. So this one started at 0, But if I take my whole graph down 3, my horizontal asymptote is now at -3. So then just move your points down. Oh, and I have to flip as well, don't I? So, if I take my 0, 1, if I move that down 3, if you flip it over the y, it doesn't go anywhere. If I take -1, 1/2, down 3, then flip it over the y, so it's going to be at +1, -2.5. And last, I have 1, 2. If I move that down 3, then flip it over the y, it goes over here. My graph looks like this. What's the domain of that? The range is talking about my y's. What would that be this time? Starting at -3 and going. All right. Questions so far?
So the parent function is just the base of the number.
Yep, just the base to the power of x. All right. Let's go ahead and talk about this. So I'm going to let you guys write this property down, then I'm going to talk about what it means. So we are going to start solving exponential equations. Today and tomorrow we'll be focusing on this. So this property tells us is you have an exponential with the same base on each side. Then you can drop those bases and set the two things equal. Okay. In other words, if I said like 2 to the 3rd power equals 2 to the x power, since there's a base of 2 on each side, these exponents have to be equal to each other. So x would have to be 3. This only works if it's set up exactly as written. In other words, you can only have one base on each side. Can't have anything else. I can't have, 2 times this. I can't have 2 squared times 2 to the 5th equals 2 to the x. It has to be just one base on each side. And then you can just drop the base and set your exponents equal. So let's start solving some equations with these. So our first problem, 3 to the x plus 1 power equals 81. Right. What I need to do in order to use this property is to get the same base on each side. I cannot break down 3, so that's just going to stay the same. But how could you rewrite 81? 3 to the 4th power. I didn't change it, it's just another way of rewriting it. So 3 to the 4th power equals 81. Now, since they both have a 3 on each side, you can drop that base and set the exponents equal. So x plus 1 equals 4, and x is 3. These equations are easy to check. You just plug back in. I put that in. 3 plus 1 is 4, and 3 to the 4th equals 81. So it does work. Right. B. 2 to the negative x equals 16. So what would we do? 16 is the same as 2 to the 4th power. So then you can drop the base, set your exponents equal. By -1 and x is -4. sometimes there are multiple ways of working a problem. This one we have a couple options. Does anyone have a suggestion? So,
You could turn the 1 over 25 into, we do negative 1 over 25 and x, do x minus 2 over 5.
okay, so you're changing them to, you wanted to flip them, so we didn't have fractions,
Yeah.
right? So what kind of exponent flips it? A negative. So if you don't like the 1/5 and you wanted to write it as just a 5, you'd have to do 5 to the negative 1. 1 over 25. So that's like 25 to the negative 1. Okay. Power to a power, what do you do with those exponents? So that becomes a 5 to the negative x equals, okay, what could I change 25 to? So you have 5 to the negative x equals 5 to the negative 2. So if you set your exponents equal, divide and you get x equals 2. So that is one option. Did anyone have a different suggestion? Okay. If you don't mind the fraction, this is 1/5 to the x. 1 over 25 is just like 1/5 squared. At that point, we have a common base, don't we? So you can drop them and set the exponents equal, and we get the exact same thing. So different options, but we will get the same answer either way. You just have to get an equivalent base on each side. Whether you change it into 1/5 or 5 doesn't matter. Why don't you guys do D for me, please? So 4 is the same as 2 squared. So set your exponents equal. So you get 2x equals 3, divide by 2, and x is 3 over 2. All right. Those are pretty good, right? Let's take a look at these. So 8 to the negative x plus 14 equals 16 to the x. Can I rewrite 16 as 8 to a power? Okay. I can write 16 as 4 squared, but that doesn't help me with the 8 because I can't write 8 as 4 to a power. But both of these could be written as powers of 2. So you may have to change both sides. 8 is just 2 to the 3rd power. And that negative x plus 14 stays, bless you. 16 is 2 to the 4th. So then with these exponents, make sure you're writing it correctly, because what do I have to do with these exponents now? Multiply them. So we get 2 to the negative 3x plus 42 equals 2 to the 4x. Now you have the same base, you have it written once on each side, so you can drop the base, set your exponents equal. So if I add over my 3x, divide by 7, and we get 6. And again, you can always check this if you put it in your calculator. What about F?
A lot of bases, you just add the exponents.
Okay. On the left, I have a problem. I have two things to multiply. But just like if I give you x squared times x to the 3rd, when you multiply, all you do is add your exponents. The base doesn't change. So I can combine these things. When I multiply them, it doesn't become a 25, it's just 5, and then you add these exponents. So x plus 1 plus 2x minus 3. So x plus 2x is 3x, 1 plus negative 3 is negative 2. Alright, if I'm going to keep the base of 5, how should I rewrite 1/5? So if you distribute that negative, you get negative x minus 4. So you can set your exponents equal. Add over my x, get a 4x. Add the 2. Get -2. Divide by 4, so x is -1/2. I think I would like to do 1, maybe 2 more, and then I'm going to stop for today. Any questions for me so far? Do you guys remember doing this? Actually, I'm not. I'm going to do, sorry, I'm going to skip around. I want to do this one. Give you a little more of a challenge. So what's my common base? 3. So instead of 27, I would write 3 to the 3rd. So power to a power would multiply those. That gives me 3 to the 6x. So then we can set the exponents equal. What are you going to have to do now? Right, it's a quadratic, so you have to set it equal to 0. And then we can factor, do box method on this one. So since it's a 1x squared, we can do the shortcut. X squared breaks into x. What multiplies to -7 and adds to -6? So if you set each of those equal to 0, you get x to be 7 and -1. So it is okay to get more than one answer on these. All right. I can't make up my mind. I'm going to go ahead and stop here, I think. Tomorrow, I'm going to do a few more examples of this, and then we may start the next little portion of this section. For tonight, what I'm going to give you is a handout. This handout is not due tomorrow. I am not going to collect it until Thursday. So it has a lot of equations on it. We've only practiced a few. We will practice more of them tomorrow. You really technically know how to do it all by right now, but you don't have to finish it tonight. So this will be tomorrow's homework too.